You're listening to the Australian Water Association podcast series. My name is Jo Taranto, and joining me is Richard Greenwood. Richard is Principal Consulting Engineer with Jacob New Zealand and is a part of the water infrastructure team. And we're discussing moving towards a zero environmental footprint dairy plant. Welcome, Richard.
Yeah, good to talk to you, Jo. Thanks for having me.
Now, you're in New Zealand at the moment and have had a lot to do with the dairy industry there. Can you tell us about how intensive the water and energy requirements of dairy processing exactly is?
Yeah, sure. Well, the New Zealand dairy industry has experienced a significant growth in the last sort of 10 to 15 years. In particular, a lot of land has been converted from sort of sheep and beef into dairying, as driven particularly by sort of the high commodity prices, and that's driven a lot of processing capacity, and the processing capacity really uses a lot of energy and water to convert effectively cow's milk into commodity products like whole milk powder and skim milk powder, and that has really significantly increased and been quite intensive. And a lot of that's also driven by the move in the early 2000s, where the government formed the company Fonterra and actually introduced legislation which really pushed the envelope in terms of dairy production.
With such growth in the industry, Richard, what does that mean for the use of water, for example?
So a lot of the dairy farms use a significant amount of water on farm. There's a whole piece which is not actually the subject of this paper, which is to do with the water use around the farm and the farming methods, and particularly in dry areas of New Zealand where there's a lot of pressure to convert land to dairy and then the use of irrigation. But what I've been focusing on is what happens when you get into the factory and you actually have to convert or produce products from the milk. And that also uses an intense amount of water. There's a lot of high amounts of water that are abstracted from the local environment, whether it's from a river or from the ground, to use for milk processing. And there is also a lot of thermal energy that's required because you actually take your milk and you drive a lot of that existing liquid off it to create these products. And that's just the amount of water that's used in that process is pretty significant. And then that water is effectively, a lot of it's used in cleaning. So there's stuff called clean in place, or CIP, where a lot of the water is flushed or used with chemicals and flushed through dairy pipes in the factory. Then a lot of that water is effectively sent off as a wastewater and then disposed of. And this huge amount of water that's used and treated or partially treated in a wastewater treatment plant is then either discharged into rivers, oceans, or discharged back onto land as a treatment source, and that has had quite significant pressure on the environment in terms of those discharges. A typical dairy plant with water requires, so for example, a large South Island dairy plant would have a consented water take during peak season of around 13,000 cubic metres per day of water, and probably discharges a similar amount or slightly less, say 12,000 cubic metres per day of wastewater. And that is a significant burden in terms of water take from that local environment, but also that wastewater discharge to that environment. And the plants also require a significant amount of thermal energy, and usually, particularly in the South Island, it requires coal to raise that thermal energy, and in the North Island it's a mixture of coal and natural gas. And that also has been receiving a lot of attention recently because of the media attention on climate change, and particularly the reliance of New Zealand's thermal industry on burning coal. So this is putting a lot of pressure on waterways and land, and particularly affecting the ability of the country to respond to pressures on climate change and to the government's requirements to move to a low carbon economy.
Those requirements to manage particular streams within the dairy industry obviously have led to traditional processing. What are some of the liquid and solid streams that have to be managed within dairy processing, Richard?
So there's a number of inputs and outputs. The key inputs really are your raw milk, which comes effectively as a liquid source from farms. Other inputs include chemicals, which are generally imported, water which is used for processing, and a lot of that water, as I said before, comes from either surface water or groundwater, and we call it an imported water. And then, of course, you've got your coal, your gas, but you've also got a load of imported electricity. There's also other things such as other inputs such as stormwater, roof water, and that sort of stuff, which come and need to be treated because it's an industrial site and also disposed of.
Is there a fairly traditional management for those outputs, Richard?
Yeah. So typically, for example, wastewater. So in a typical process, the water which is imported or extracted for processing is used for cleaning of the process plant, and that would typically be then discharged to some form of wastewater treatment. And it varies across the country, and it's actually very similar in both Australia and New Zealand, where in some cases it's not treated at all to reasonably sophisticated treatment.
What opportunities then does a technology like zero liquid discharge present to the industry?
So in a zero liquid discharge plant, it takes a circular approach, and what it looks at is all of the liquid inputs and looks to see how it can be reuse those liquid inputs. In terms of zero liquid discharge plants, and this technology around the world is becoming much more established, and there are a number of examples of that. Effectively, it takes in wastewater, looks at doing some sort of pre-treatment, maybe putting it through some sort of membrane type or reverse osmosis plant, producing a water reuse stream, which is then reused back into the production in some form, and then usually produces some sort of brine or solid material, which in a lot of cases can be used as some sort of fertilizer or in some sort of solid disposal method. In Fonterra, they're actually doing this in some limited way. What they do is they actually take some of the discharge, so some of the liquid which is produced during the process, which is the water that's driven off when they make when they dry off the milk into a solid, and that water, which is funnily enough called cow water or COW water, is recycled through these membrane filters and actually reused in the clean in place process. So there's a sort of a partial reuse carrying on there, but in a number of plants around the world, they're moving towards the zero liquid discharge. And it pretty much involves very common technologies like reverse osmosis, ultrafiltration, evaporation and crystallization, thermal type processes. But the next step is to take that zero liquid discharge into potentially a product contact situation, which would require further odour removal, further disinfection and mineral dosing to meet pH requirements, and effectively making that treated water or reused water to a drinkable standard, or even better than drinkable standard, so it can be used in that third product contact situation.
Are there other technologies and processes then that will shake up this traditional linear approach to processing?
Yeah, so there's lots of things that can also be added into here. So for a zero liquid discharge plant to move towards the zero environmental footprint plant, we have to look at all of the inputs and all of the outputs. So that we've talked a bit about the liquid inputs, but there's also some solid inputs as well. But there's also the energy inputs. And in terms of getting a full use of all of those things there, you've got to really integrate all of those three things together. So that's solid, liquid, and energy. And I've talked already about the fact that these plants are a very energy intensive process. One of the things that we've been looking at in Jacobs is the use of the resource recovery facility and the use of wastewater and combining that with potential hydrogen technology. And that is where we can take the wastewater treated and then run that through some sort of hydrogen technology to produce hydrogen, which could then effectively be then reused back as an energy source for the dairy industry. It also treats further the water and produces oxygen, which is a byproduct in a hydrogen facility, but that oxygen can actually go back into the wastewater treatment facility as pure oxygen rather than using aeration, which then effectively saves a lot of energy for aeration in the wastewater treatment plant. And then the hydrogen electrolysis also effectively, there's more water available in your wastewater than what you need for your process plant or your process heat. And so for a dairy industry, there's effectively hydrogen available for potential transport. And for a company like Fonterra, for example, or for other large dairy companies, they rely on a large transport fleet to move raw milk from farm to factory.
So a zero environmental footprint plant is achievable in your opinion?
It is. There's a few things that would need to be worked on. First of all, some of the hydrogen electrolysis technology is still very new. And some of the things that would need to be worked on is trying to get the cost of that technology down. Some of the modelling that we've done recently has shown that coal is still a very cheap energy source, particularly in New Zealand, and from a pure cost point of view, doesn't quite stack up yet to the cost of actually doing hydrogen electrolysis. However, if you looked at some dairy factories are actually converting immediately away from coal and actually raising steam or converting their boilers directly to electricity from the grid. And in that case, their hydrogen production becomes a bit more cost effective. We've been looking at the use of MABR, which is membrane aerated bioreactors, which as part of the wastewater treatment process are a much more efficient wastewater treatment process, which reduces the amount of energy inputs and is ideal in a setting where you've got a hydrolysis plant, because you can use pure oxygen, which is the byproduct of a hydrogen reaction, to use in an MABR for the wastewater treatment phase instead of aerating it with air.
What would you say to those people looking to move to a more circular approach for the dairy industry?
I'd say that it's achievable. It's a long-term goal and a long-term view that I think the industry needs to take, and there's significant benefits for it. So one of the things I forgot to mention was that when you have a dairy factory which has got some form of hydrogen generation, if that dairy factory is powered off the grid, which uses renewable energy, for example. So, for example, in the South Island of New Zealand, you've got pretty much almost nearly 100% renewable energy from either hydro or wind. Then effectively, the electricity inputs into the plant are all renewable. Your hydrogen production is completely circular. You actually end up with a very low carbon or approaching a zero carbon plant. By recycling and reusing all your water, you're getting a complete reduction or almost to zero. And of course, there's obviously the improved customer perceptions as well in terms of your customers that you're selling to, but also for all of the stakeholders and the community around you, that you're actually doing something which is moving towards a circular economy.
It certainly sounds like a huge amount of opportunity. I've been speaking with Richard Greenwood, Principal Consulting Engineer with Jacobs New Zealand. Thanks so much for your time, Richard.